Hello guys, I know I'm posting a little bit late, but we have 19 questions. I found this paper for probability for more practice, so I will go over it really quickly. What's the probability of obtaining a head when a coin is flipped? You can have either heads or tails. So coin is a fair or balanced probability, so this will be 1 over 2 and this will be 1 over 2. So that's the answer, for the first one. Second one, a die is rolled twice. So we roll 2 times. Find the probability of rolling 2 sixes. So we have the probability of 6 and the probability of 6. The probability of getting 6 on the first die is 1 over 6, and in math means times, or in math means plus. So you can get 6, we need 6 and 6, so the probability of 6 is 1 over 6, and is times the probability of getting 6 again, which is 1 over 6, so then we get 1 out of 36. Now, 03. An experiment of rolling 2 tetrahedral dice, 4-sided. The score is the product of the numbers the 2 dice land on. So they're asking us first, how many possible ways are there for scoring 4? You can do 2 times 2 to get 4, or 1 times 4, or 4 times 1. So we have 1, 2, 3 different ways. Now what's the probability of scoring 4? It's going to be 3 out of the total possibilities, which is 4 times, again, because it's 2, 4, so the total possibilities is 16. So 3 out of 16 we will get then. Actually no, it is in simplest form. So now, an experiment consists of rolling 2 tetrahedral dice. Again, the score is the product of the numbers. How many possible ways are there for scoring 2? You can get 2 either by 2 times 1 or by 1 times 2. So it is 2 out of the total probability, which is 16. So then if we simplify it, it is 1 out of 8. Now, an experiment of rolling 2 tetrahedral dice, 4-sided. The score is the product of numbers. What is the most likely score? So we have 4 sides. 1, 2, 3, 4. 1, 2, or let's do it like this. Then 1, 2, 3, 4. Or no, wait. 1, 2, 3, 4. So we have it like this. If we're gonna multiply, here we're gonna have 1. Here we're gonna have 2, 3, then 4. Then here it's gonna be 1, 2, 3, and 4. Then here it's gonna be 4. Then 2 times 3 is 6. 2 times 4 is 8. Then 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 4 times 2 is 8. 4 times 3 is 12. And 4 times 4 is 16. So what is the most common or most occurring score? If you notice, it is 4. So 4 is the most likely or the most occurring score. Now 6. An experiment consists of tossing a coin. So first you have to toss a coin, then rolling a dice and observing the outcomes. Find the probability of obtaining a multiple of 3. So first of all, in tossing a coin, we can get either heads or tails. In rolling a dice, you can get a number between 1 and 6. So the probability of obtaining a multiple of 3, you can either get head and 3, or head and 6, or tail and 3, or tail and 6. So you can substitute the probabilities, or you can count that it's 1, 2, 3, 4 out of the total probability. How do we know the total probability? We're tossing a coin. What is the probability of tossing a coin? It is, you can get 2 possibilities, either heads or tails. You're rolling a dice. What's the possibility of rolling a dice? 6. You can get any number between 1 and 6. So the total probability is 2 times 6, which is 12. So you can put 1, 2, 3, 4 out of the total probability, which is 12, and so then you will get 1 out of 3. Now, an experiment consists of tossing a coin and rolling a die and observing the outcomes on the faces of each, okay? Find the probability of obtaining a tail. You can obtain a tail. 1 and tail, 2 and tail, 3 and tail, 4 and tail, 5 and tail, 6 and tail. So these are 6 possibilities out of the total, which is 12. Then you will get 1 over 2. Now, an experiment, okay, it's the same thing. They need now the probability of obtaining a tail or a multiple of 3. Here I think they did a mistake. I think here they meant and. So here they want the probability of obtaining a tail and a multiple of 3. So to do that, we need the probability of a tail, and in math means times, and then the probability of a multiple of 3. So probability of tail is 1 over 2, and in math means time. The probability of obtaining 3, a multiple of 3, times 2 out of 6, and then we are gonna get on the calculator, if you do it, you will get 1 out of 6. Number 9. Here I think they're asking for obtaining a tail or a multiple of 3. So the probability of obtaining a tail is 1 over 2. Or in math means plus obtaining a multiple of 3. We know the probability of obtaining a multiple of 3 is 2 out of 6. But of course we have the common, so the intersection. So what are we going to do? We're going to take this and we're going to subtract it from the intersection. What's the intersection? We said obtaining a tail is tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. And obtaining a multiple of 3 is head 1, head 3, head 6, or tail 3, tail 6. If you notice, we have tail 3 and tail 6 repeating. Now, these are two possibilities. So tail 3 and tail 6 are two possibilities out of the total, which is 12. You can simplify it or put it in this way. In your calculator, you will get 1 over 2 plus 2 over 6. Okay, then you subtract it from the common, which is 2 over 12, and then you will get 2 over 3. Number 10. Here, we draw 3 people can pass. So they will either pass, alright? So we have either pass or fail. If they pass 0.3, if they fail 0.7. If they pass 0.6, if they fail 0.5. And if they pass, it is 0. Sorry, my bad. Here it's 0.4. Here if they pass 0.5, here if they fail 0.5. So now they need the probability that all 3 people will pass their driving test. So 1, 2, 3. Then it is pass times pass times pass. So then you do it, and on your calculator you will get 0.09. Now here they said they need the probability at least 1 of the 3 people will pass. So anytime you see at least, you do 1 minus the complement of the probability. So the complement is that no one will pass. What's the probability of no one passing? It's 0.7 times 0.4 times 0.5. Alright, so if we do it, 1 minus 0.7 times 0.4 times 0.5, you will get then 0.86. So our answer here is 0.86. Now, the probability that 3 people will pass their driving test are this. Find the probability 1 of the 3 people passes. Okay, they need exactly 1 to pass. So either first can pass and the other 2 fail, or the first 2 fail and the last one passes, or the first one fails, the second one passes, and the third one fails. So this is a very complicated case. So if the first one passed, it would be 0.3 multiplied by second one failing, which is 0.4, times third one failing, which is 0.5, or in math means plus. If the first one failed, the probability is 0.7. If the second one failed, the probability is 0.4. If the third one failed, the probability is, if the third one passes, then the probability is 0.5. Or the first one failed, probability is 0.7. Second one passes, probability 0.6. And finally, third one failed, probability is 0.5. If you do it all on your calculator, you are gonna get 0.41. Now, the probability that Tareem has eggs for breakfast is 0.4, and the probability she has cereal is 0.6. So this is our tree diagram. Okay, they're telling us, if we go down, find the probability that Tareem has steak for lunch. She can have either eggs for breakfast and then steak, or she can have cereal and then steak. So if she has eggs, it's 0.4, and means time steak is 0.3, or means plus cereal, the probability is 0.6 times the probability of steak, which is 0.7. And if we do it, 0.4 times 0.3 plus 0.6 times 0.7, it will be 0.54. So here the answer is 0.54. Now, the probability that a person in a certain large group is left-handed is 0.2. If two people were selected at random, find the probability that one person is left-handed. They need only one person to be left-handed. So you can either have left-handed and not left-handed, or not left-handed and left-handed. So you write the probability. Left-handed is 0.2 and mean times. Not left-handed, the probability is 0.8. How did we get it? 1 minus 0.2. Or in math means plus. The probability of not is 0.8 times the probability of left-handed, which is 0.2. You can do it this way, or you can directly do it like this, however you like. So then you will get 0.32. Now, a library has 20 science books. So fiction, we will say 20. Comedy, 30. In total, there is 50 books. Now, 3 books are chosen. 1, 2, 3. At random from the library. And I am assuming they are not replaced. So let's say they are not replaced, because based on this, it seems they are not replaced. Okay? So they need to find the probability that all 3 books are comedy. The probability of the first being comedy is 30 over the total, which is 50. But now we took 1 from the comedy and we took 1 from the total. So now here it is 29 and here it is 49. So now the probability of comedy the second time is 29 over 49. Then again we took 1 from here and 1 from here. It became 28 here. It became 48 here. So the final time is 28 over 48. And then if you multiply, you will get 29 over 140. Now, a drawer contains 8 blue, so blue is 8, 6, black. Let's say blue is 8, black is 6, and red is 3. They need the probability it is red. We don't know. Okay, a pen is selected at random. So 1 pen is selected. What is the probability it's red? It's 3 over the total, which is 17. Total is 17. So our probability is 3 over 17. Number 18. A bag contains 4 blue marbles. Blue is 4. Yellow is 8. Okay, total is 12. A marble is picked from the bag without looking at it and putting it aside, meaning it's not replaced. A second marble is then picked from the remaining marbles. Find the probability that the second marble is yellow. Now here, you can either do it their way, or you can follow this rule. If before condition isn't given, then probability is as if the first. Now look, it's 12 in the morning. I'm sorry if I'm a bit sleepy. I want to explain that well. But I'll go into a bit details here. So if the condition isn't given, if before condition isn't given, they told us a second marble is picked from the remaining marbles. They need the probability the second marble is yellow. They didn't tell us that the probability, what is the probability of the first marble. Like here it says, it could be blue and yellow, or it could be yellow and yellow. Okay, but us, we know that it is not given. So since it isn't given, we're gonna take it as if the probability, as if it's being the first time being picked. So we're gonna take the probability of the marble being yellow as if it is 8 out of 12. And if you do 8 out of 12 on your calculator, you will get 2 out of 3, which is the same answer as their way, even though they did it in a longer and more exhausting way. Now, finally, last question, then I can go to sleep. And I'm sorry if I don't explain that well because I'm tired. A bag contains 4 blue marbles, so blue is 4. And then 8, then yellow is 8. A marble is picked from the bag and then another. Find the probability that the second marble is yellow, given that the first marble is blue. Okay, so now we have what? We have that the first marble is blue. Alright? Since the first marble is blue, we know that the probability of the first marble is gonna be 4 out of 12, 4 out of the total. But now this isn't gonna benefit us, it's just extra information, okay? They need the probability of the second marble, not the probability of getting blue and yellow. They need the probability that the second one is yellow if the first marble was replaced. So now we cannot apply what we did in the question before because we have the before condition given, okay? But instead they're asking us if it was replaced, so we took it and we put it back, meaning the blue will stay the same, the yellow will also stay the same, and the total will also stay the same. All right, what's the probability that the second one is yellow? So it's gonna be 8 out of 12, which is 2 out of 3. Why? Because there is there is replacement. Now finally, the last thing, if the marble was not replaced, it was not replaced, meaning that you took it. So our blue was 4, our yellow was 8, and our total was 12. You took one blue marble, so now -1 here and -1 from the total. Here we have 3 and here we will have 11. So now the probability of getting yellow the second time is 8 out of now 11. And that is it for this paper. Thank you guys for watching. I know it's like 12 in the morning and I'm sorry to post it this late.